Thank you.
All right. Thank you so much. So first of all, good morning, good afternoon, and good evening to all who are present in this third and final session of this inspiration workshop on importance of modern IT architecture in evolving data ecosystem. My name is Samrat Maske, and I work in UN Statistics Division under Data for Now initiative and support the work in cross-cutting IT architecture. Next slide, please. This series of can you go back to the previous slide, please? I just want to link. This series of inspiration workshop is organized by UN Statistics Division under Data for Now initiative and seeks to inspire countries on the various ways to leverage innovative approaches to improve data-driven decision making. All three workshops are directly linked with each other. Can you just go back one more time? Thank you. Sorry. The first workshop highlights the impact of partnership with data producers and users to produce statistics that meets decision makers' needs and showcases examples from countries on how they are leveraging partnerships and produce relevance. The second workshop focused on using innovative data source methods and methods to produce statistics based on the decision makers' need that we identified in the first session. And then this third and final workshop will highlight the importance of IT architecture to manage the data lifecycle of innovative data source methods and technologies. Next slide, please. Next slide, please. Thank you. So this is a brief agenda for today, and I'll try to highlight the evolution and importance of modern IT architecture, along with strategies and lessons learned from Data for Now work in various countries. We also have respective speakers from NSOs from Vietnam, Mexico, Maldives, and Senegal, who will share their knowledge and experience on modern IT architecture and how they utilize to foster innovation. Next slide, please. To set the stage, let's talk about why modern IT architecture matters. The data ecosystem is evolving at an unprecedented pace. It is driven by new technologies like big data, and now AI and ML joining the race. And we saw in previous sessions where countries shared experience on using new and innovative data sources and methods like mobile phone data, satellite data to produce various indicators. Hence, modern IT architecture has become really, really essential to maintain the relevance, efficiency, and ability of NSOs to meet the emerging demands from various data decision makers. It is actually a backbone that transforms the siloed and rigid system into an interconnected, flexible, and scalable system that fosters innovation. However, there are challenges. We all know this. And then we need to mitigate them and move forward from them. Challenges like managing complex data flows, ensuring security, and so forth. Next slide, please. Let's take a step further back and look how data ecosystems have evolved in national statistics offices. Initially, we collected data, and our statisticians and analysts computed indicators and saved them in files. This system is still in use, but when there is a lot of requests, the limited resource that we have in our national statistics offices and maybe in the national statistical system itself gets overburnt by the demand request of the new data. In addition to this, it also produces silos when we save various data. Different statisticians or analysts produce different data in different files. Sharing of data also becomes very difficult and siloed. Next slide, please. Can you press enter? Thank you. To resolve this issue, so we moved from this manual process towards a database where we created some ETL processes where we extract, transform, and load the data in some databases. And this database became our single source of truth. This resolved in some cases, somehow it resolved some of our previous issues, but as we identified it, these initial databases were transactional database or row-oriented databases, which meant that we could easily add or edit different data, but we ran into the complexities when we tried to query multiple data, when we tried to query multiple tables with complex queries. That although it generated the results, it took very long time, and in many cases it failed the query itself. Can you next slide, please? Thank you. So to resolve that, we moved towards the data from database to data warehouse. It basically is just a column-oriented storage that stores the data in different schemas like star schema or snowflake schema. What it did was allowed us to run complex queries in an instance. It allowed us to merge different queries. But sometimes maybe the updating was a little, adding or updating was a little slow. However, it resolved a very complex part. And then this in itself, if we have up to a data warehouse, already is a mature system that we have. But if now we are trying to move towards innovative approaches, and then when we are trying to get different data sources that are not even structured, it becomes very difficult for us to load these data.
Samrat, I think you are muted.
Maybe someone muted me. Can you hear me now?
Yeah, perfect. Thank you.
Okay. So I was just mentioning about the data warehouse still had some complications to store innovative data sources. Next slide, please. And this is where we maybe move towards the custom ELT processes where we load our data and saved it in some locations. This allowed us to load different sources of data. But if it is a one-off process, it's okay. But when we have multiple these kind of a pipeline, it becomes difficult to manage it. Next slide, please. That's why we slowly move towards a data lake architecture, whereby it helped us to manage multiple data pipelines and then save structured and unstructured data that allowed us, our data scientists and engineers, to create pipelines and run different methodologies to create new indicators. Then there were other technologies came like data warehouse and so forth. I'm not going there at the moment. But it doesn't mean that with all of these different data flow, it doesn't mean that the one data flow replaces the other one. In fact, I want to highlight that they complement each other as we move forward. Next slide, please. And as we look into the data flow and evolution of the data ecosystem, let's break down how data flows within a system and link this process with our existing global statistical business process model. Here in this picture, I've tried to highlight the data source, ingestion, and storage process of the data lifecycle, and link it with the data collection phase of the global GSBPM method. And then after this, after these three processes, we have The data transformation and processing, that belongs to the JS BPM processing stage. And then the last one is analytics stage of the dissemination. I'll try to explain them with a sample example in the next slide. Next slide, please. So let's look into a possible data flow in any national statistics office. The first column, the leftmost column in this picture, represents an innovative data source that we're trying to pull. This could be a mobile phone data, a satellite data, a social media data, admin data, or any other new forms of data that we're trying to pull. And maybe we are pulling it, maybe we're getting it, these data as maybe email, or maybe we're getting it as a database connection, data API, application connectors, or FTP, whatever the form that be. We pull the data through data ingestion tools that is shown in the second column, the green column, that extracts the data from the data source and delivers to the storage section. This could include tools like low-coding tools like Apache NiFi, Pentaho PDI, Airbyte, or so forth. Or maybe some National Statistics Office have very strong IT team, data science team, and then they run custom codes like Java or Python to pull the data and store it in the database. The third column in this picture is the raw secondary, is where we are storing the raw secondary data along with our primary data sets that we already have, like our sensors and surveys. We need to optimize it for consistency, performance, cost, and scale. We need to remember this very importantly. And then the fourth column here that is in our picture, maybe operational process. This could be a record linkage, for example, whereby we are cleaning the data, linking the data between our innovative, the secondary data source and our primary data source, and then storing it in our data storage again. Then finally, maybe we are running any other innovative methods to produce the required statistics and then disseminating this result of the new indicator that we just created based on the innovative method. So in this process, there is also a cross-cutting section at the bottom that entails entitlement, security, workflow manager, metadata management, and many more actually, which are very important part of the process that I just wanted to highlight here. Next slide, please. And the same data flow that I just explained, when we put it into architecture view, and then as we are only focusing on innovative approaches, I'm just leaving the other data flows that I explained at the beginning of database, data warehouse, and so forth, and then focusing a little bit towards data lake technology landscape. And then I just have put together data lake technology landscape, whereby the first column again is the same data source. These could be sensors, surveys, social media, and others. The data collection process as it is in the middle. The second one is the ingestion process, whereby we are using tools like Apache NiFi, Airbyte, Kettle, Java, Python, so forth. Then we have our storage section in the data lake. Starts with the storage platform. The most popular one, the early adopters of the data lake started with the Hadoop ecosystem, which still is very popular, but I think it is a little more expensive in terms of maintainability and deployment. And then there are object storage like S3, MinIO, which are the new ones that are coming, which are a little cost efficient to store. This is one of the data storage platform. And then within the data lake, there are data storage formats like Parquet or ORC, which allows encryption and encoding along with compression like Snappy or zzip. It allows that enables us to store large volume of data in a very small size. And then we could always make this data lake into a data lakehouse by creating SQL query engine like Presto or Trino, or in the case of Hadoop ecosystem, Hive. And then we could then transform this using data modeling or analysis using Jupyter Notebooks, Python, R, and so forth. There's also special. There's also this the last visualization section whereby we could embed the generated statistics into reports or dashboards and so forth. And then the last at the bottom, we still have this orchestration workflow managers. The most important is governance, entitlement, and security. Although this is a reference architecture, every NSO has different architecture need use cases as they move forward. With this, I hope I have given a brief overview of the evolution and importance of modern IT architecture. And then I want to move towards sharing some of the lessons learned during the deployment of the Data for Now work in the countries. Next slide, please. Yeah. So a few of the lessons that I want to share is it is very important that when developing a modern IT architecture, that we are in alignment with existing oversights and accountability mechanisms so that data remains secure, private, and protected throughout every step of the data life cycle. And then IT architecture decisions made by NSOs must comply with the applicable legal regulations, ethical guidance, and legitimate stakeholder expectations. Next slide, please. It is very well known that to acquisition of IT services, data systems, or other solutions related to the processing, storage, exchange of data is complex and time-consuming. So we need to plan ahead as we move ahead in the journey of more modernization. And then we also need to be sure there are numerous open source and proprietary options available, and NSOs must weigh in their relative advantages and disadvantages across multiple dimensions like vendor lock-in or acquisition or operation costs, maintainability, sustainability, and so forth. Next slide, please. I also want to highlight that the data governance also is a very, very important factor and is a key. We need to make sure that users in different roles and teams have access to the data that they need, and they should not get access to other data that do not have permission to. So it is very important in that context as well. We ensure data governance. Next slide, please. The most valuable resources that we have in our National Statistics Office are staff, and then we need to make sure we have staff with proper knowledge and skill. So the ability of a National Statistics Office to efficiently integrate multiple data source and generate efficient statistics needs competent and staff that have learned the skills, because these are new technologies, so we need to invest a little bit more. And then while we are also deploying this, the new architecture, we should consider the skill set of the staff, what they already know, and then move in that direction. Next slide, please. Another important factor that we identified while the deployment was the importance of a cross-cutting functional team. The collaboration between teams and statistical production team is essential for successful implementation of new data architecture. The modernization of IT architecture requires open communication and empowerment of all team members, IT, statisticians, and so forth. Next slide, please. While modernizing our IT architecture, it is very useful to implement agile methodologies like Scrum, which delivers tangible results and continuous improvement in short iteration. It just does multiple iteration as we progress. And this digital transformation efforts requires flexibility and changes course and then there is a lot of requirement changes as we progress. So I think we need to be very agile and adaptable as we progress in this modernization effort. Next slide, please. And since we are dealing with this new and innovative data sources, we need to ensure that our architecture that we have deployed can handle growth of data. And while the data grows, it should not incur the cost of it should be able to handle the data growth without incurring exponential cost growth as well. And then it would be really good if we could implement some automation and orchestration tools to facilitate the execution of this whole data lifecycle from data ingestion, processing, analysis in scale. Next slide, please. The most important of them, of the all solution thing that we have identified is there is no magic solution. There is no silver bullet. The right architecture and solution will be different for each NSOs, and even within the same institution, within the different area, it may be different. So it totally depends on the number, volume, and nature of the data source that is being used, the skill set of the team members that are using it, and the use cases that they are trying to implement it. So we just need to make sure of this and then move forward in that direction. Next slide, please. My final thoughts, quick summary, is that modern IT architecture is the backbone of this evolving data ecosystem. And then the goal is continuous improvement. We cannot just deploy everything at a go. It is very expensive. We need to train our team. We need to invest in our infrastructure. So we need to take a slow step. We need to start with a slow proof of concept maybe, and then move in an agile way. And then when we are sure this is the solution that's gonna deliver the result, then we can move towards putting it in a production system and making it an enterprise solution to the overall organization. But this does not mean that the legacy system cannot coexist. Legacy systems should exist, and the new system should try to incorporate them as much as possible. And another thing is like what has worked for one country or one unit or one team may not work for other team. So we need to be ready to adapt to our own requirement and modify as it is needed. We need to do a proper cost-based cost-benefit analysis and invest in upskilling the NSO's staff skills along with the infrastructure to make it scalable, flexible, and secure to foster innovation. Next slide, please. All right. This was what I hope sets a stage for our next speaker. Initially, there was a Q&A session, but I think what I will try to do is like have two more of our speakers first present, share their experience, and then I will, after two speakers present the session, then I will open the floor for a Q&A session. So I will give the floor to our colleague from Vietnam, Mr. Do Noi Ha from General Statistics Office of Vietnam. Mr. Ha, to you.
Yeah. Hello, everyone. My name is Ha. I'm come from General Statistics Office Vietnam. Today I would like to share experience how we apply the data lake architecture in my country. Next slide, please. First, once I would like to introduce structures of the statistics lesson system in Vietnam. We in my office is a general statistics office under Ministry of Investment Planning. We have the statistics in whole country from the 63 province. That's we call the province statistics office, and at the district level we call this district statistics office. However, in ministries, each ministry we have one statistics division, the responsibility for statistics for ministry. In this workshops, I would like to sharing how we using data lakes, and let's learn. We think you can learn what is data lake architectures we apply to sharing statistics database. Next slide, please. Before we apply the data lake architecture, we very different to the manage micro data. Special is sharing data sharing step. We don't know the after we deliver micro data for the partner. We don't know what we win analyze with our data and what's the reasons. Maybe the analyze without the weight, or maybe something like that. So maybe this reason falsifies or not true. So when we apply this data lake, we user analyze our data. This data lake architecture can support us efficiently any process and analysis and dissemination in the both database, traditional and non-traditional. Before this data lake architecture can support any types of database. Next slide, please. Methodology we work in this project. UNSD, the data for now project support us to implement the data lake after many meeting, virtual meeting. Project suggest us to use this data lake architecture. This very suitable for NSO to sharing data. Next slide, please. Yes, diagram of data lake architecture. You can see it's includes 4 columns. First column is shows the data source. That means that data lake support to here you see we can FTP file or can get data from the internet or from any database. But database it supports any formats of database such as Microsoft SQL or Oracle or R or SPSS or Stata data. And second column question. This we use Aperture file to collect data from the input to the store. This Aperture file is open source. This is, can allow us to get directly data from the data source to input to the store. It's easy. And the third column is a storage. This we use Minio tool. It's also open source. This tool allows we can storage the data as any data types from the any data source. And this tool can allow user can access to the folder to access data or correct the reason to store in the Minio. And the next one is very important. This that's same the get of for its interface to contact with the end user. End user have the demand to analyze the data. They can go here and access the data, which data they have access right, and analyze. We use Jupyter notebook. That's we call the Jupyter Hub. In here, we can integrate many statistics tool. Example R, Python, or Stata. However, now we use R and Python because, as you know, Stata we need to license. Next slide, please. The reason study now we think this data lake architecture very useful with ZO because its own tool is we choose is open source, so the solution very costly. Data lake supports any inputs data type, as I talked before, and we can integrate with statistics tool for the user can analyze data directly. And we can manage and sharing microdata as a security policy. That means user can it's data from, but they cannot download raw data. It's a very important point. As I mentioned before, we have this solution. We don't know how end user can use our that way, and not sure, and we don't know may they share for or any other people. And that's why this solution can integrate with Microsoft Active Directory. That means now if in the office you Microsoft Active Directory, so end user can have only one account. They can access here. They don't need to remember any other passwords. Next slide, please. Continuous results. So until now, the ZO is implemented data lakes for data sharing with the two survey data. We are using data share labor force survey and VSLSS in this data lake. For we share for user in our office. We automatic share with our data sharing policy. Now user from the department responsibility of to this data can have asset right, and if any NSO NCO have a request to CSO, we will share to them to can access this data lake to analyze data directly from the micro data. Before that, we if any NGO requests to access the data, we have to deliver micro data to them. So through that solution, more statisticians can access a survey data. I think any NSOs can apply this data lake architecture. It's very efficiently and secure. Next slide, please. So for next step and recommendation in our office, my leader to approve our plan for the next steps. We will implementing for own survey data. However, with the last survey data, we will require last the IT infrastructure. So we have to upgrade data center. It includes the server and storage. And on the requests to analyze data when doing in data lake, we organize training to using R, because we expect R when is the main tool to exploit data in the data lakes. And we also would like to develop one software by themselves to manage own request to access the micro data and analyze data. So the recommend for us to everyone, NSO can choose this solution to apply for data sharing, because it's a very useful and costly. Every tool is open source. Next slide, please. Conclusions. As I talked before, the data lake architecture is open source tool, so it's suitable with NSO. And data lake architecture is very easy to implement. However, it's need IT to enjoy to operation, because when we assign or we create the asset rights for end user, they do by command line. In geographic interface is very very less, so operational people have to applauded with IT. The data lake architecture have the good performance to increase data and can management capacity for NSO. Next slide, please. The last one, I would like to thank Data Flow project to support us implement this solution for ZSO. So I hope the Data Flow project or NSD can continue to support to introduce with other country to implement this solution. However, this should this project should fund with data license because many NSO very familiar with data, not familiar with R. So the next one after this workshop, any information can contact with me through this email in the screen. Thank you, everyone.
Thank you so much, Mr. Ha, for sharing your knowledge and experience on implementing the on-prem data lake architecture in GSO Vietnam and using it to share the survey data across NSOs and NGOs. So thank you so much for that. We will continue to have one more presentation, and then we will take a Q&A for these presentations. In the meantime, if you have any Q&A, please do put it in the chat. So with this, can you please go to the next slide? And I would like to welcome Mr. Elio Villasenor from the Data Science Lab of INEGI, Mexico. To you, Mr. Elio.
Thank you, Samrat, for the presentation introduction. Well, my name is Elio Tenogenes. I am director of the Data Science Laboratory at National Institute of Statistics and Geography of Mexico. Our lab focuses on delivering data science and modern IT infrastructure to drive innovation in the process of statistical and geographical information production. Today, I would like to tell you about INEGI's advantages in data infrastructure, integration of innovative technologies, and lessons from implementing data lake architecture. Next slide, please. The objective of the presentation is to showcase how INEGI is modernizing its IT architecture and delivering data science to enhance statistical and geographical information production. Next slide, please. At INEGI, the evolution of information technology development and adoption have focused on strengthening the data architecture. A key milestone was the implementation of data warehouse technology, which enabled the consolidation of various statistical information products and optimized their production, from microdata processing to the generation of tabulations for end users. This infrastructure primarily integrates structured data and metadata, facilitating the automation of reports and tabulation generation. Currently, it serves internal users within the institute and also powers the institutional portal, providing access to external users. Since 2020, INEGI has been experimenting with the deployment of a data lake architecture based on an open source components. This initiative stems from the Data Science Lab need to leverage alternative data sources and innovative methods to generate data products that add value to information production processes. To achieve this, emerging technologies such as machine learning and artificial intelligence have been explored. Thanks to the flexibility of the data lake, it is possible to integrate data views from the data warehouse, allowing these sources to be utilized in new analytical and information production pipelines that can be automatized. This experimental technological deployment has been successfully tested in various production units, highlighting the need to integrate the data lake's processing capabilities into the Institute cross-functional information technology platform. In this context, the integration is envisioned under the data lakehouse concept, enabling users to seamlessly access to both the data lakehouse, the data warehouse, and the data lake. This unified approach will stimulate processes, enhancing analytical capabilities and information production. Next slide, please. Thank you. Successful integration requires close collaboration across various areas of the Institute, particularly with the information technology teams managing the data warehouse and the production units that will utilize this technological platform. But collaboration not only includes internal and particular valuable experience has been the collaboration with National Institute of Statistics of Chile, which has adopted our data lake architecture proposal and is currently incorporating it into various production processes. This partnership has served as a significant proof of concept, demonstrating the scalability and impact of this technology in modernizing statistical processes. Our technology integration approach is based on the use of open source libraries and the adoption of standards developed by the statistical community. For storage, we use Menu, enabling connectivity with various database formats. These data sets can be virtualized using Presto and efficiently queried with Hive, which supports SQL-based queries. For data analysis, we primarily rely on Python libraries, though R is also used in specific use cases. To process large volumes of data, we leverage Apache Spark. For data visualization, we utilize tools such as Apache Superset and eCharts, while the geospatial data we use GeoServer. This technology integration will be available on GitLab and releases for the use of statistical offices community, particularly in Latin America, as part of the binational project developed in collaboration with the INE of Chile. Next slide, please. Thank you. To fully harness advanced artificial intelligence in statistical production, a robust technological infrastructure is essential. At NEGI, we rely on high-performance on-premises environment supported by dedicated data center and IT team for maintenance and support. This setup ensures operational efficiency, data security, and long-term sustainability. Maintaining this infrastructure on premises is particularly strategic, as it mitigates the high recurring costs associated with cloud-based solutions for AI and machine learning workloads. It also enables better cost control, resource predictability, and the seamless integration of a statistical data workflow. Next slide, please. Thank you. One example of the application enabled by our infrastructure is illustrated in the following diagram. The process begins with the integration of diverse data sources into our data lake. These sources include traditional statistical data, geospatial information, web-based data, and third-party datasets requiring special confidentiality and security considerations. By consolidating these heterogeneous sources, we can build high-quality training data sets for developing and fine-tune foundation models. Foundation models are pre-trained deep learning models designed for general tasks such as text processing and image analysis. For instance, we leverage large language models like Mistral to generate content related to statistical data. Similarly, we utilize models such as SAM, Segment Anything Model, for image segmentation, and also EfficientNet for satellite image classification. These open source models are deployed in our on-premises infrastructure, ensuring data security and computational efficiency. We have already developed and tested several of these applications in production environments, demonstrating their effectiveness and enhancing the statistical processes. Next slide, please. INEGI is advancing in deployment and consolidating of its institutional data lakehouse to achieve full interoperability across the institute. By implementing standardized governance and security frameworks, the platform will be fully integrated into production processes, enhancing efficiency and reliability. Additionally, infrastructure expansion will enable real-time processing, scalable storage, and seamless integration, ensuring robust foundation for data-driven decision-making. Beyond internal improvements, INEGI is fostering regional collaboration by sharing best practices through workshops, working groups, and open source initiatives. Strengthening partnership with regional and international organizations will promote the adoption of interoperable solutions and alignment with global standards, enhancing the capacity of national statistical offices across the region. To further enhance analytical capabilities, INEGI is investing on AI-driven infrastructure by expanding high-performance computing resources to support machine learning and artificial intelligence applications. The development of AI-powered tools for automatic data processing, predictive analytics, and statistical innovations will enable more sophisticated and timely insights. Next slide, please. INEGI's sorry, it was yes. Next slide, please. Thank you. INEGI is modernizing its data infrastructure by integrating its data warehouse and experimental data lake into an open source institutional data lakehouse, delivering high performance and on-premises infrastructure. This transformation eliminates data silos, optimizes resources utilization, and strengthens governance, ensuring scalable and efficient data management. By enhancing interoperability and analytical capabilities, this modernization empowers national statistical offices to fully leverage data science and artificial intelligence for more advanced and timely statistical analysis. Furthermore, INEGI is fostering regional collaboration by sharing best practices and promoting interoperable solutions, enabling the NSOs to adopt similar innovations and strengthen data-driven decision-making across the region. Next slide. And that's all. Thank you.
Thank you so much, Elio. I think what INEGI has accomplished in creating an institutional data lakehouse or moving towards it, I think it's really remarkable. And thank you for so much for sharing your experience on removing these data silos, fragmented data, and those challenges. I think these are really valuable experience. I hope we will be able to learn from you, and then hopefully the NSOs would also take note of these advantages that you have accomplished with this institutional on-prem data lakehouse. With this, I will open the floor for any Q&As. If you have any questions or so forth, please do raise your hand, and then I will ask Abu Tuere, you have your hands up. If you can unmute yourself and ask any question to any of the speaker.
Good afternoon from Freetown, Abu Ture, the National Economist of UNDP Country Office in Sierra Leone. Thank you very much. I think the three presentations are very much informative. So, and it's for me, it's all the presentation, they provide a lot of guidance to the National Statistics Offices globally. So, but you know, no specific question to any specific, but general. Let's talk about the skills gap.
Mm-hmm.
The skills gap, because I think the first presenter mentioned the issue of the changing ecosystem, you know, in the statistical compilation and processes. So now we have all these gadgets, we have all this information and tools to use, but then you notice that you know, in many of our national statistics offices, there is a big skill gap to use and utilize this kind of tools that are available for them to improve on the quality of data, on the processes. So I don't know what's being done to bridge that gap, because until they are able to use what is available, and I know it's also a learning curve because like you mentioned, we started off with paper and then move on to CAP or PAPI or whatever it's referred to now. But at the end of the day, a human being still has to make use of those tools. So how is this human capacity developed in the National Statistics Offices? I think this is something I believe that this process should also be able to address if they're going to harness this technology. And lastly, I would want to ask also about where do we end? I think you mentioned all the processes that you outline all of them, from data collection and analysis. But of course, I understand also you mentioned that it's a cycle, right? So where should the process end? At what point we think this data maybe is no longer relevant? What do we do with such information? We delete or whatever, we throw away or we archive or whatever. So I think it's important for National Statistics Offices to know, even within the legal framework, where to end a certain process. For example, we have a labor force survey, and we have huge data sets that have been processed or being processed. Where should they end, you know, going forward? Thank you very much.
I think really, really valid questions, Abu Tuere. Thank you so much for your questions. Do anyone want to take this question? Elio or Mr. Ha, and then maybe Elio first.
Yes, thank you. Well, related with the skills gap, one strategy that we are implementing is to develop training programs for all the staff of INEGI. And we have seen that the young people have already these skills, have developed these skills in their new students programs and bachelor's programs or master's degree programs. They already know these data science program languages, and it's very easy for them to acquire these capabilities. Maybe it's just a generation change that we are experimenting. Yes.
Thank you so much, Elio. Mr. Had, any response to the questions? on capacity building, or how do you handle the data life cycle?
Yeah, it's very interesting questions. So as I know, so this the data lake solution I present when we use the Apache Wi-Fi and Mineo, this allows to collect directly to the data source. We can manage the data life cycle from after the finish survey production system. We can collect the data directly to the data lake. In a whole data life cycle from the analysis and dissemination step, we can manage in two this step of the data. For the handling the system, this data lake architecture allow us to implement on-premise. So we can do very secure in our infrastructure IT. That means we can honor the system, and we can operate by the time when the data being announced. That's all. Thank you.
Thank you so much, Mr. In addition to this, I also want to add is like, in addition to what Elio also mentioned, the individual training programs within the NSOs that they are promoting to upskill their in-house staff. We also, through Data for Now, also provide trainings in capacity building programs. Various other international agencies are also providing capacity building trainings. So that could be another avenue from where countries can learn a little bit more of the technology. And hopefully this inspiration workshop also will add more curiosity as to why other countries are adapting these technologies, and then maybe learn themselves as well. Hopefully this would add to the curiosity and then provide more learning platform. In addition to that, on your question on the relevance of how long you need to store your data and so forth, I think it totally depends on country-specific case, their legal mandates and so forth. But with this data lake technology, one thing we had tested was when they were storing the data in data lake storage using Parquet format or so forth, the data file reduction was almost 90%. So instead of 10 gig file, it was only 1 GB file. So the file storage was also reduced. So that could maybe help a little bit more on archiving the data if you have to archive it longer. Hopefully this answers your question. I think we are running a little out behind time. I saw one question in the chat. I'll try to answer it there directly in the chat. And then I would like to move to the next presenter, Mr. Irfan, Mohammed Irfan from Maldives Bureau of Statistics. Irfan, to you.
Thank you, Samrat. Hello, everyone. My name is Mohammed Irfan from Maldives Bureau of Statistics. I'm going to tell you all about building a modern storage system to integrate administrative data in our office. Okay, next slide. Yeah, so I'm from Maldives Bureau of Statistics. We are the lead agency of Maldives Statistical Systems. we are responsible for providing official statistics on social, economic, environment, and other key sectors. Next slide. So in this presentation, I will outline some key benefits, technical considerations that we took, and the practical approach we have used to implement this storage system, and the capacity building programs that we did inside our IT department. And the objective of this was to implementing a secure modern storage system to integrate administrative data. Next slide. So initially our existing data collection process was by email. This included CSV files, Excel, PDF, this shared through the email as attachments, and physical media also, with large data sets coming through USB or external hard drives. So the challenges we faced with this method was security risks, as like data breaches or unauthorized access, data integrity issues, like files may get corrupted because the files are being shared using USB drives, and we didn't have any version control, so there might be multiple versions of the file created, so there might be inconsistencies. Data loss due to USB drives or hard drives, there's a chance of getting the files damaged, or the devices being damaged or losing it. Inefficiency and delays. Physically transferring the data is slow compared to cloud-based solutions, so the delay is obviously there through the existing data collection process. We had limited accessibility because the data is stored on a physical media, so it's not readily available for remote access. Next slide. So to address these challenges, our approach was to develop a data lake storage solution using Minayo. We chose Minayo because it was open source, and it provided data collection through its push-based approach, enabling data owners to directly upload their dataset into a secure environment. Minayo was chosen because of its scalability, high performance, and secure data transfer capabilities. It had exceptional throughput and low latency, so it was possible for large scale data transfer. Minayo has Amazon S3 capability, so the support for API ensures us for smooth integration for existing tools and applications as well. So the methodology we have used is an agile methodology for this project. We divided the project into manageable phases, so that we can validate each deployment phase as we moved on. So initially we prepared our infrastructure in a cloud-based environment. We chose Azure cloud service, and we created a virtual machine in our cloud service. Next, we deployed Minayo in a single node, single drive configuration, and then we did the security implementation using access control mechanism as well. Next slide. So the implementation of the data lake setup, we used a 3-tier bucket structure. We used a raw bucket, processed bucket, and an archive bucket. So the raw bucket basically stores unmodified data for transferability. It preserves the data integrity and simplifies management. The Process bucket will hold transformed structured data for analysis. We used ETL scripts to operate the raw data to generate usable information stored. And then the archive bucket retains compressed version of the original files for long-term storage. Next slide. So we used Minayo web console. The web console is solely for the data providers so that they can log in and then upload the data through the console. So before that, we created buckets, and then we did the configuration of access policies, and then we granted permissions. We did version controlling so that they can upload the data once everything is done. For example, the data flow for transport ministry, we tested statistical sources leverages the three-tier bucket structure together with the Python ETL scripts to automate the flow. So the transport ministry data was uploaded as raw PDF files containing the statistical information on various vehicle types and the accounts to the designed raw bucket in Minayo. So once they uploaded the data, we used the Python scripts to process this data and then use it to make it more readable in a structured way. And then we remove once the processing is done, we removed it from the raw bucket and it's archived to the archive bucket. Next slide. So the initial challenges that we faced is the deployment delays because we tried to use Kubernetes and Docker, but because our capacity and knowledge, we didn't really understood these technologies. So there was a delay in our deployment there. So we had to choose other technologies. We had a limited infrastructure because we didn't exactly have a data storing server in our premise. So, and we have security vulnerabilities because we didn't have a mechanism of opening our servers to the public. So the solution, as I said, we identified was Minayo object storage because it had it was open source and it supported various file formats, and we could give access control depending on the way that we want, so that we have control on how people, users or data providers will access the platform. Compared to physical server, the cloud-based service was cost-effective, so we had we could implement it and run on a small budget rather than purchasing a physical server, which was much more expensive, and it was not doable for us at that moment. Minayo provided a high performance architecture because large data sets can be uploaded through Minayo. Yeah, next slide. So the skill gap that we had and the capacity building we did, we had Linux administration training. We had limited experience in Linux because we are almost we are using Windows based services, so our Linux experience was limited. So we had to go through some training on Linux, which was conducted with hands-on workshops to understand, to manage the servers and the concepts better by using Linux commands. Advanced scripting, because mostly the Python was limited from our perspective, because not everyone was familiar with Python. So we did Python training as well, because we needed to automate our scripting so that these files can be moved from the raw bucket to the process bucket and to the archive bucket. So we needed more training on Python as well. Object storage management, we had a limited understanding on it as well, because unfamiliarity with MinIO specific features. So practical MinIO management sessions was conducted with hands-on training as well. Data security practices, we had basic understanding on encryption and limited knowledge on access control. So we did hands-on practice with MinIO security features, with secure data access by setting access keys and granular level access to control policies to ensure that only authorized scripts and users can interact with the MinIO platform. DevOps methodologies, because we had lack of understanding in DevOps as well. So we did some training on DevOps fundamentals like Docker as well, to gain some knowledge there. Next slide. So the next step for us will be, the recommendation will be the server-side encryption to enhance data security, implementing a server-side encryption with KMS is recommended. This feature will automatically encrypt all data stored in MinIO by safeguarding the sensitive information from unauthorized access. And our next step will be data and application integration, because both raw and aggregate data with various analytical and visualization tools like Apache, Superset, or Power BI is recommended for streamline data workflows. By connecting MinIO with platforms such as Jupyter Hub, data catalogs, GeoSolver, and similar applications will enable efficient analytics, data discovery, and geospatial analysis. Yeah, next slide. So before I finish, would like to acknowledge UNSD for this initiative, and especially its moderator Samrat, whose guidance and supervision was key for us. And I would also like to thank Visha, our local consultant, who played a critical role from planning to deployment in this project. I would also like to thank our senior management for their immense support, and agencies for providing us with the data. Thank you.
Thank you so much, Irfan, for sharing your experience and knowledge on implementing the MinIO server and building the capacity from ground up, including Linux administration to DevOps. So I think that's a really good accomplishment in itself, to have this data lake storage in place in MBS. So thank you so much for sharing this. I think we are running a little behind schedule. So maybe I will go directly to our last speaker. I will hand over to Mr. Borum Mane, Head of IT Division, to share his experience on modernizing IT architecture. To you, Mr. Mane. I think your mic is, we cannot hear you, Dr. Mane. We can see you, but we cannot hear you yet. We still cannot hear you. Is it possible maybe you can switch on and switch off your mic? Maybe that will help. We still cannot hear you. Is it possible? Otherwise, you connect through your phone or so forth.
Hello, you hear me?
Yes. Thank you so much. Now we can hear you loud and
Hear
clear.
me?
Yes. We can hear you. You can maybe proceed, Mr. Mane, if you can hear us.
Can you try another method by refreshing your laptop and coming on again?
Mr. Mane, we can hear you. Oh, no, not again. What can we do?
Hello, hello.
Yes. We can hear you now. Sorry for the technical issues. While Mr. Mane tries to fix his computer, if you have any questions, or please do put it in the chat box. But in the meantime, Mr. Mane, can you try to refresh your computer or so forth? if not through the mobile. I see you have just joined.
Hello, Samrat. You hear me?
Yes.
Yes, but it's echoing. It has some.
Now it should be okay. Try to speak, please. No, it didn't work. I think you are muted, Mr. Mane, one more time.
Mr. Mane, could you try speaking now? I think it should work.
Okay, thank you very much. I'm sorry for the difficulty. So I have to present it the importance of modern IT architecture in evaluating data ecosystem and how is UNSD using its modern technology stack. My name is Dr. Bourama Mane, head of IT division at UNSD Senegal. So my presentation will cover the following points. The first is the importance of modern data infrastructure in national statistical system. So how UNSD modernize its IT infrastructure technology stack. The next is what does the country use this modern technology stack, and the last will about the status and lesson learned. Next step. So for the context, the adoption of implementation of modern IT architecture play a crucial role in the evolution of the data ecosystem. It is the backbone that support the collection, the storage, analysis, and exploitation of data, increasingly complex and interconnected environment. Next. So for the importance of modern data infrastructure in national statistics system, this important of modern data infrastructure is to offer a big data management capability to enable the management of exponential volumes of data generated daily by various sources. So using the tools like Adobe and Spark that offer parallel processing capability, the possibility of integrating data from diversified source for the data integration and transformation tools, the API that facilitates the merging of data from different sources. Next. The importance of modern data infrastructure is also to offer the opportunity to strengthen security and compliance, the possibility of using artificial intelligence and advanced analysis, the resilience and high availability, promoting innovation and interconnecting ecosystem. To contribute also the cost reduction and durability. Next. So how UNSD modernized its infrastructure technology stack? UNSD have modernized its infrastructure, adopting an architecture tailored to each need. So we have acquired a full internet access link to the operator. The 4 internet access link are configured with 2 firewalls. We are configured in redundant mode. This configuration is also do with the backbone with 4 switch, and all these switch are interconnected with 2 nodes of server. We have a production server, and we have a test server. All these environments are connected with the remote access sites for backup all data that we have in the central level, and all our services that are in the regional level is connected with the VPN with the central level. That is our architecture that we have implemented for modernize our IT infrastructure. Next. For this modernization, we have established of the National Survey Data Architecture Platform, that is the rich catalog of more than 200 survey and censuses covering various fields. For this field, next. We have agricultural field, we have power support, we have employment and other fields that are implemented in our platform for access all data that are product on the in the UNSD. Next. The modernization has also enabled to implement a platform for processing and analyzing the statistic data. In this project, the platform called Data for Now platform. We have implemented that by the different sources like SPSS, like Excel, Stata, and others database. So we have do the first step, which is the injection and the processing using open source software like Daxter, and for the storage and access all the data, we have used Mina.io configured with our Active Directory server that allowed all users to access today's data. And for the analysis, to do the analysis for all this data, we have used a navigator with Open Jupyter Notebook, and use software like Stata, like Python, like R, for doing all the analysis and processing that we are doing for this data. Next. So where does the country use this infrastructure? This modernization has also enabled to implement a data innovation lab project, which serve an integrated center for research into the economic and management of innovation, focusing on the role of the data revolution and in shaping in innovation and entrepreneurs. This is a new project that we implement for using the IT infrastructure, for using all the application or software, open source software, to doing research, to indicate, to localize all data that we can use for the platform. Next. So where does the country use this modern technology stack? The first is a micro access center that we have implemented to the Senegalese university. The objective is to facilitate the use of survey data for analysis and research purposes. The implementation of the pilot phase has started with the University of Dakar. We have installed the center, and the next step for us is to doing the same for Gaston Berger University, Alioune Diop University on Bombay, and the last is the Asansek University of Ziguinchor. So that is a project that we have implemented for facilitate the access of data for all our researchers, for all the external users that want to access to some type of data like micro data and others. Next. So the next use of this infrastructure is to implement project like Gistan. Gistan is a new project that we have do for using public data and private data. The objective is to accumulate all these data and have a security of data through a specific infrastructure. After that, we can do all the analysis for this data, private and public, and that kills to set goal, editing, founding, seeking, associate, data protection infrastructure, statistic analysis, machine learning, exploitation of results. Next. So now for the study and lesson learned, the implementation have offer to user a data center for the National Statistical System. That is a data center that can store all the data product in their services. The use of open source solution, that is also the opportunity that we have. All our experts, all our researchers can use this open source platform for access to data, for doing the analysis for all data that we have stored in the data center. The opportunity given to the user to exploit and the software functionality of Python, R, and Stata. A secure management of survey and survey metadata. That is the possibility that the implementation of our IT infrastructure offer to our user. The next, that is the presentation I want to share with us, and I'm available for your question. Thank you.
Thank you so much, Dr. Mane, for sharing your experiences and knowledge, and then the progress in SD Senegal has achieved in a very short time. Started with a small data lake. Now you are moving towards Data Innovation Lab. So congratulations on all the achievements that you have accomplished so far. So with this, I would like to open a floor for 1 or 2 questions to our speakers. If you have any questions, please do raise your hand. Otherwise, we are also running a little behind our schedule. So if I do not see any hands, I would like to then thank Mr. Mane, all our speakers, Mr. Elio, Mr. Ha, Irfan, and Dr. Mane for sharing your experience, and move to our, I would like to invite Ms. Yonggi Min, the Chief of SDG Monitoring Section of UNSD and the OIC of Development Data and Outreach Branch from UNSD to close our session.
Thank you very much, Samrat. And dear colleagues, as we conclude this 3 days inspiration workshop series on the Data for Now initiative, I would like to express my sincere gratitude to all participants, speakers, and also our organizers. So over the 3 sessions, we have explored key aspects of modernizing the national statistical systems to produce timely, relevant data for the SDGs. So our journey covered 3 critical areas. First, partnerships and engagement across the data ecosystems with valuable insights from Kenya, Morocco, Dominican Republic, Colombia, and Seychelles. Second, innovative approach demonstrated by Palestine's geospatial info integration and Tunisia's satellite image analysis, Vietnam's small area estimation, India's citizen data, many innovation in Ghana, and Uruguay's mobile phone data usage. So finally, today's session highlights the modern IT architecture's vital roles. with inspiration example from Vietnam, Mexico, Maldives, and Senegal. So I'm very impressed by your openness to finding effective solution and willingness to overcome these challenges with novel approaches. Through the data for now, we have helped strengthen country capacity and to use diverse data sources, methods, and tools, and contributed to directly to SDG monitors. So special thanks to our donors for their support, our technical partners for their collaboration, and also to Samira, our colleagues for organizing these workshops with many others colleagues. So I encourage you to maintain this connection and continue sharing experiences through the Data for Now network. The UNSD team remain committed to support your effort. So on this website, the slides, you can see how you can subscribe to our newsletter. You can visit our website for more information. If you're interested in receiving more support, please contact us. We have an email address left. So thank you all, and I look forward to seeing your innovative solution implemented in your country. Thank you. Back to you, Samara.
Thank you very much, Yonggi. So with this, I think we close the last of the 3 webinars, and I would like to one more time thank again and close the session. Thank you.
Thank you.
Thank you.
Thank you, everyone.
Samrat, I see a question,
Thank
but I think
you.
we have answered that before.
Yeah, thank you. That was a good answer and I enjoyed it. I liked it. Thank you. Thank you.
Thank you so much.
So interesting. Thank you.
Wonderful.
Thank you, everyone.
Thank you very much.
Exactly,